Hello and welcome to our broadcast titled HTTP Session Caching with Redis Enterprise. It is a pleasure to introduce today's presenter, Adi Folger, Solutions Architect at Redis Labs. Increasingly, companies are turning to Redis Enterprise to handle the parts of their infrastructure that gets hit the hardest and has to weather the storm. In this session, Adi will discuss how you can use Redis Enterprise as your HTTP session store and ultimately lower your page load times without compromising stability. Today's broadcast is being recorded. Following today's event, an email with a link to the recording will be sent to you for sharing with your fellow workmates. We will be taking questions throughout the broadcast, and those questions will be answered in the order that they're received. There is a question and answer feature in the control panel that you can use to post your questions. Thank you again for joining us today. And at this time, I'll turn the broadcast over to Adi. Adi, take it away.
Thanks, Sharon. So as Sharon mentioned, my name is Adi Folger. I like to call myself a professional geek with Redis Labs. And Redis Labs is the open source home and provider of Redis Enterprise. We provide Redis Cloud, Cloud Private, on-prem, and various different permutations of a fully professional grade Redis implementation that you can lean on as a as a core part of your architecture. That's a very important aspect of what I'm going to be talking about today, because sessions are something that definitely needs to be able to scale. So similar to like when you're going through airport security and they tell you how to buckle a seatbelt, I just want to make sure that we're all on the same page about what a web session is. I'm assuming most of you probably already know this, but stick with us for maybe the couple of you that don't. So web session is a way of tracking a user from a page view, from page view to page view. It's tracked in a cookie, and its internals can be seen by the browser and any third party watching the traffic, unless the traffic's encrypted. Sessions are generally seen as transitory and used to, and due to the issues around securing them, oftentimes people will use these kind of transitory goods or tokens as a session identifier and keep all of the actual important information such as usernames and behavior tracking all server side. So because you have the ability to see who a user is from page view to page view, they're often used for personalization purposes, used for authentication, behavior tracking, etc. And it's the most commonly used data point by any modern website, so it's very important that you be able to scale it. Oftentimes what will happen is when you go and you receive some kind of traffic spike that might be related to some kind of seasonality or a specific event, or because you had a particular thing that went viral, most of the time what's going to happen is this session store is what's not going to scale, especially if it's coupled to the rest of your data platform. So Redis is built for this more transitory style data, and it's something that it's specifically good at. Why is this important? Statelessness is a very key design for RESTful services. State has to live somewhere, though, and it's something that your database latency is going to end up being baked into the page load time. Redis being very fast, it's often very kind of naturally seen as a way of tracking this data. And the important thing to understand is how many pages does a user load in a given session? What are their pathing? How much do you know about their behavior? And increasingly this becomes more and more important because the personalization nature of what you're doing, of your application, essentially kind of can make or break you versus your competitors. And it's becoming one of those things that you have to be able to have in order to maintain parity with other applications out there as well. So what are your options in terms of dealing with this problem and providing this, this session storage? You can push your state into the browser client. As I mentioned, there's a lot of security risk because this is essentially then clear and open to the user. And it also slows down the browser. So it's one of those things that you have to take the pain somewhere, and that essentially is a lot harder to control. It's much more variable because you have a bunch of different kinds of browsers, a bunch of different kinds of users and computers, etc., versus being able to optimize it in an environment that you control and understand, which is your data center or your cloud deployment, however you have your application running. The other option, which is very common up until probably about 3 or 5 years ago, was to cache the session data on the web server. Unfortunately, this isn't actually stateless, and it makes it so that you can't take advantage of the growing number of tools, Kubernetes, Mesos, Docker Swarm, etc., that are able to manage these stateless services. And it pushes your complexity into your networking layer, which requires session pinning, and it's much harder to scale in that aspect. Both organizationally, because I know that a lot of times network orgs within the business are probably the most hardworking and overworked. And as well, there's a lot of expensive hardware that you need to be able to have in order to do it right, which most startups don't normally have. So really your best option is to be able to use a database of some sort. So what's very important is that you select a database that can support this idea specifically. And what I'm talking about here is the overall amount of latency required in order to process these multiple different calls to your database. And it's going to change probably from page view to page view. Sometimes you're going to be adding data. Sometimes you're going to be reading it, and read-to-write balance is very important. And that's one of those things that Redis Enterprise offers a one-to-one balance on, which is not to be the case usually for most other database platforms. So in this case, I'm going to be talking about traditional SQL versus Redis, and the complexity involved therein. So let's start with SQL. SQL is generally disk-based, but it has some relational benefits. Most likely you're probably already using it somewhere, but it requires a lot of extra work to be able to deal with transitory data. Most of the time you don't normally want to delete rows. It's just not seen as a very common operation. So you have to build additional logic around that, and it's slower usually, and it's harder and more expensive to manage and scale. Most of the time you have to have at least one member on staff that's kind of dedicated to managing that in order to really get the best performance possible. In contrast, Redis is cheaper and easier to scale. We have enterprise-grade scale and support. And we have a lot of features built in to support this whole transitory data model. So automatic key expiration, intelligent eviction policies, various data structures that are flexible. And as we go down this path of personalization, what that ultimately means is machine learning. And coming up very soon is going to be things like a neural net module, which will allow you to essentially seed data into your machine learning models very quickly and easily without necessarily having to rebake your entire architecture or have to build an entire data warehousing platform behind your traditional database. As well, and as always, Redis is seen as a very fast option. And what I was saying before around the overall time that your application needs to process any given page view becoming more and more important is something to keep in mind here as well. The other option that I want to highlight, because this is normally what people will start, is you putting SQL or putting Redis on top of SQL. What this does is add an additional layer of complexity and management. You do get the benefits of Redis without having to necessarily change the entire way that you think about your data, but it is a little bit more complicated and has more places that you have to think and manage. So to give you an example of what I'm talking about here, I created essentially a strawman application that shows the difference in the complexities here. So of course with SQL you always have to start with a table. This is a very contrived DDL. However, it speaks to the idea in and of itself where SQL is less flexible than Redis. You have to be able to track data. You have to really, to get the best performance out of SQL, you have to understand your data much more natively. Versus Redis, you can just kind of throw things in there and it's a lot easier to use, and I'll explain that more here in just a second. I have two different objects. One is a Postgres data proxy or data object that allows you to get and set session data. You have to write out the SQL statement, and this is a very basic implementation. This doesn't also include all of the necessary security things that would be required, such as SQL injection prevention, error handling, etc., versus Redis, which has a much simpler implementation. This whole thing is basically half as long. And I know lines of code are kind of an arbitrary way of measuring complexity, but in this case, especially since we're talking about a starting point or a strawman argument, it's one of those things that just kind of stands out. And architecturally, it becomes much more complicated as well, as I'm sure many of you are aware. And that's where Redis Enterprise kind of steps up and allows you to lean on it as a core part of your architecture and to alleviate a lot of the stress and pressure around scaling SQL. Are there any questions? So one of the questions that I'm getting is, why can't you use the caching built into SQL? And you can. However, you still then have your database, your SQL database, as your essentially monolithic point. And that doesn't necessarily make it easier to scale. It just makes the specific query faster. And sure, at the end of the day, that might end up being roughly the same in terms of the end user's performance. But whenever you get to a point where you're going to have these spikes in traffic, that doesn't necessarily scale in the same sort of way. Also, most of the time when we're talking about the personalization aspect, you then have to build out this whole back-end platform processing in order to manage the machine learning model part of the equation. So you would have to have this additional ETL that then loads data into Spark, and or for example, to Spark, and then you have this kind of reverse or this feedback loop that you have to create. And that's an immensely more complicated way of approaching it, rather than directly feeding your data into this machine learning model and then using that same model to power the personalization features that you have that you want to use. Another question that I have is, how will my application change if you choose Redis as as my caching layer? And the answer is very little. One of the ways that I've approached this is to use the decorator pattern, where you essentially just throw a decorator on top of a function, and then it will go in and cache it for you. Normally, you would use either some combination of the method signature, so the function name and then the args, or you can use the, in the case of like just caching SQL, you can take and make a hash, say like an MD5 or a SHA-1, of the SQL text itself, and then that creates a unique key that you can use to cache it. And in addition, Redis offers this native expiration feature, so it's just one more line of code to say, hey, expire this, rather than having to track an additional column, make sure that that column has the logic built in, and then you have to deal with manual expiration, etc. Next question is, does Redis have persistence built in? And the answer is yes. Redis Enterprise offers persistence all the way down to the single write level, in contrast with the open source, where it's only available at every second. As well, there's a high availability features that ensure that if anything goes wrong, that you will have uptime within seconds rather than minutes, or having to deal with it manually, which is oftentimes the case with the database. And that's really kind of the difference that I wanted to highlight here, is that you should be able to manage the scale in a very professional way. And the difference between scaling Redis and SQL is like night and day. SQL, you have to manage all kinds of different problems. You have to make sure that you have these big beefy machines that are out there. And the high availability model is just a non-trivial thing, versus with Redis Enterprise, all you have to do is check a box, and then you all of a sudden have high availability. And it's a beautiful thing. Next question is, should I use Redis for write-heavy or read-heavy workloads? This is what I was talking about before. Because of Redis's architectural design, it's one of those things that read and writes are the same. They would both be treated essentially as O of 1 in a simple situation. In the examples that I was using before, I was using the hash data type. And essentially where things become significantly dramatic is when we start talking about dealing with subsets of the data. So if you're looking closely, you saw that I was probably throwing a JSON into SQL versus putting these native data types into Redis, or using the hash data type in Redis. So I mentioned before, on any given on any given call, you're going to probably be working with a different part of the data. And so leveraging the hash data structure allows you to be able to only have to interact with the subset of the data, which is an O of 1 operation relative to the data size. The way that you can do this with SQL is to separate this out into different columns, but you then have to have that baked into your application. You have to have that baked into the database. It's not something that you can do very easily. And that actually then leads into my next question, which is, does Redis have a schema? And the answer is yes. However, it's not the same that you would think of in a SQL sense. You don't have to predefine it. The schema is essentially the key name. So normally the example or the way that you want to name your keys is going to be application name or some kind of prefix that denotes what the application is. In a microservice-based world, this allows you to potentially have Redis be the backend for multiple services. Then you would have a colon and then the data entity name, so in this case a user, and then a colon and then an ID number or a GUID or some way of identifying that user, and then at the end any sub-attributes. So a very common idea that we talk about is a social media website and showing relationships between other users. It's also a very common thing found in personalization engines. The whole idea of, a user likes these pieces of content on my website and this other user likes these pieces of content on my website. This other person has these other things that they like and they have this much in common. So therefore, user A, which will probably like the same things that user B likes within a certain percentage. And this is the basic premise behind recommendation engines. And with these more machine learning driven data types that we're going to be coming out with at RedisConf here in the next couple months with the Redis module system, it then allows you to handle this natively, which reduces the overall architectural complexity as well as improves the performance of the application as well. The next question is, there's also a pub sub mechanism within Redis. Is this recommended? For what I'm talking about, it wouldn't necessarily be suitable because pub sub is extremely ephemeral. It's much more suited to broad scale messaging, so like one-to-many messaging. And it's one of those things that if I send a message in a pub sub channel and there's no listeners, it just goes away. So there's a chance that you might lose data. The way that you can deal with this, if data delivery is an important thing, and the analogy that I like to use is TCP versus UDP. Pub sub is generally seen as is more like UDP in the sense that it's kind of for broad scale messaging rather than guaranteed delivery, is to use a list data type to create a queue. And there's lots of libraries out there that provide essentially like syntactic sugar around this whole idea of a producer-consumer queue. The most commonly used is one called Resquue, R-E-S-Q-U-E, that originally was a Ruby library that's been ported over to pretty much every single programming language that I've checked. So that allows you to essentially throw messages into there. And I was actually talking yesterday with some people about how by putting Redis as the intermediary layer between your application and your analytics process, you can actually create a buffer. And one of the cool things that's generally lesser known is that you can actually plug Spark and Redis into each other. So you can process live stream data from Redis using Spark natively. And so if you're interested in a more of a streaming style model and you're already leveraging Spark, this is a really cool way to hook things together. As well, again, going back to that neural net data type, you would essentially be throwing data into processing without it affecting or dragging down your application practically at all. Most of the time, any given Redis call responds back in about a millisecond or so, versus generally about 100 milliseconds, 50 to 100 milliseconds for a SQL database. So that adds up over time and becomes very important. And I'm being told that we have no more questions, so thank you all very much for stopping by and listening, and enjoy the rest of your day.
Hey, thanks, Addie. Great topic with lots of interest. Hey, to learn more about session caching, register today for RedisConf 2017 at redisconf.com and take advantage of the multiple sessions that are being planned. If you register by April 15th, you will be entered to win a $500 Amazon gift card. Thank you for joining us today. An email will be sent with a link to the recording of today's broadcast. For an overview of upcoming webinars, please visit redislabs.com and register. Bye for now.